Hello, welcome to Chapter 1, Section 5. Today we're talking about another type of graph that we can make using quantitative data. So in our section with the categorical data, we talked about bar charts. Today we're talking about histograms, which look a lot like bar charts, but specifically it's used for quantitative data. Part where the data was grouped together based on the categories that it was in. A histogram is going to group similar values together into a bar. To make histograms instead of our other graphs like the dot plots or the stem plots is because histograms are better for large sets of data. So when you're dealing with dot plots and stem plots, you had to list out like every individual data point versus in a histogram, you're just grouping things together. So it's easier to count, easier to see, easier to summarize. So something we don't like about histograms is that you can't actually see individual values because in the stem plot you can actually go through the plot itself and read like, oh, this is the data point that stands for like 17 or something. But in a histogram you can't because you just see bars. Like our bar chart, you're going to label the x-axis with your quantitative variable of interest, and on the y-axis it's either frequency or relative frequency, depending on which one is asked for. Use this example data over here, how many pairs of shoes do you own, to make a histogram. So here I have my axes drawn. With my x-axis, I've labeled it with the number of pairs of shoes that people own. That's my quantitative variable of interest. And then on the y-axis, we'll pretend that we're being asked for a frequency histogram. So I'll just label it with frequency. Otherwise, it would ask you for a relative frequency histogram, and then that's when you change it to relative frequency. Need to scale both axes. So because we have numbers as our number of pairs of shoes and numbers for our frequency, we're going to need tick marks on both the x and the y-axis in even increments. That's what I mean when we are saying scale the axes. But before we can do that, we actually have to decide how many bars do we want in our histogram. So in a bar chart, the number of bars was just determined by how many groups you were making. So in a histogram, we actually get to choose. Normally we choose the number of bars based on like a general rule of like 5 to 7 is a good number of bars to have because that's when it's the easiest to see what type of shape you're going to end up with in your graph. How many bars we want in our graph, then we actually need to see what numbers will go in each bar. To do that, you're going to take the biggest number in your data set minus the smallest number in your data set and then divide by how many bars you want. This formula will give you how wide you want each of the bars. We also call that width, the class width. Look at our data. We have a biggest number of 38 and a smallest number of 1. So if I were to subtract right now, I get 38 minus 1 is 37, and then we're trying to split up 37 evenly into like, we'll call it like 5 bars. Not nice numbers, kind of sucks. So what we can do though is kind of round our biggest and smallest numbers so that when we divide, we end up with nice numbers, just to make our lives easier. So since I know I want to split things into 5 bars is generally a good number to make for your histograms. If I round my smallest number to 0 and then my biggest number to 40, as long as we include all the numbers, you can like round up or down. As long as you include your biggest and smallest numbers, then we can round that way so that really I'm looking at 40 minus 0 for my max and my min, and then divide by my 5 bars that I want to get a nice even number of 8. When I get a class width of 8, that means in my first bar, then I want numbers from 0 up until everything except 8. So like 7.9 or something like that. And then, but all the numbers in my data set from 0 up until 8, not including 8, would go in that first bar, and that will determine how tall my bar is going to be. Then the next bar will go from 8 up until 8 plus 8 is 16. So then my next bar would be all the numbers in my data set that are from 8 up until 16, but not including 16. So the number on the right side of the bar we're never going to include in the bar previously. So here's how I like to write it out. X-axis, I'm going to start at 0 because that's what we called our rounded nice minimum number. And then since I know my class width is 8, I'm going to add by 8 to get to my next number, add by 8 to get to the next number, add by 8 to get to the next number, add by 8, add by 8. And then at my last one, 40, this will include that 38 in there as my last biggest number in my data set. So what I mean by in each bar, so like let's say my first bar goes from 0 to 8. All the numbers when I make this bar, I'm just going to be counting up in my data set all the numbers that I have between 0 and 8, but I don't include 8. So I'm going to count up this 1, 2, 2, 3, all the way up to 7, but I don't include 8 because these 8s are actually going to go into the next bar. So from my next bar of my graph, I'm going to take all the numbers from 8 to 16, not including the 16. So in each bar, the right endpoint, like the 8 of the first bar, in the second bar, the 16, that number would count as the right endpoint. In my third bar, the 24 would count as the right endpoint, and so on. That right endpoint number never gets included in the bar before. So this bar right here would not use data values of 24 to count my frequency. So that's how we're counting it. I'm just going to do a little quick table here to count up all the numbers that I have between 0 to 8, 8 to 16, 16 to 24, and so on. But here we go. So from 0 to 8, all the numbers in my data set from 0 to 8, but really it's up to 7 only because we're not including the 8, there were 16 of them. So if you count all these numbers here, there's 16 of them. Hopefully I counted correctly. And then for my second bar, 8 to 16, so I went from 8 all the way up to the numbers that fit into up to 16. So the 18 does not get included. So up to 13, there were 8 of them. And then 16 to 24, that was only the 18 and the 22. And then 24 to 32 was only the 25 and the 27. And then 32 to 40 was just the 38. So there is my frequency table. If you remember what that is. So these are the frequencies that we're going to be graphing on our histograms. Know my highest frequency is 16. That means on my y-axis, I just need to make sure I include up until 16 or more. Probably easiest would be to go by 2s or something. My y-axis and scaled it going from 0 up until 16, and then we can start drawing our bars. So my first bar from 0 to 8 should have a height of 16. So drawing that out. It's really hard to draw on the computer. There we go, close enough. My next one is from 8 to 16, and it has a height of 8. So that would be right here. So notice with this histogram, because this is a histogram and not a bar chart, all of these bars will touch because all of the numbers are right next to each other. We're not doing like types of groups or categories. So that's why in a histogram, all the bars have to touch. My next bar went from 16 to 24 with a height of 2. Same thing with my bar from 24 to 32, has a height of 2. And then the last bar has a height of 1. There's my histogram. So with this histogram, now that it's done, you can definitely see the shape of it because we've got a lot of short bars on the right side. So this graph is going to be skewed right. So earlier I said when we figured out how to group the data, the number of bars we said we usually want to use like 5 to 7 bars. And there's a reason for that. Those are like nice numbers for us to use in terms of how many bars, because when I look at these other examples here, so these are 2 histograms of the same set of data. So it's talking about like percent foreign born residents or something like that. But look at this first graph where it has 1, 2, 3, 4, 5, 6 bars versus the second graph has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bars. So 5 to 7 is generally a nice number because if you look at the graph where there's 6 bars, it's a lot easier to see the shape because you can see this nice like little outline. It's definitely skewed to the right. Versus with 11 bars, it kind of breaks it up a little too much because now you have all these like little discrepancies where it like kind of dips down, and it's not as nice to see the shape of the graph. So that's why when I say like the number of bars that we want, when we divide by that number, we usually want to choose 5 to 7. A lot of your homework problems on your tests or quizzes, I will tell you how many bars to make because I need to make sure that all our answers are going to be easy to grade and similar. So I will tell you, but in general, we usually choose 5 to 7 bars and not too many like 11. We also want to be able to compare histograms. So if we have a set of data, but it's talking about two different groups, then we can compare those two different groups with histograms. When we compare, we're basically just making two histograms, but we have to make sure that on the x-axis, it's the same on both histograms. That's how it's going to make it easy for us to compare. So set of data, but this time we're splitting into two groups where we have part of our set of data is from people who prefer to shop online, and then the other half of our data is from people who prefer to shop in the store. But this is still the same pairs of shoes that people own. So with this same set of data, originally we made our bars have a width of 8. And because we're still have the same numbers as our min and our max between the set of data, it's probably the easiest to go with the same width so that we don't have to adjust for either one of these. Because when we're dealing with the same x-axis, when we're trying to compare our histograms, we want to make sure that they're the same, so it's just easiest to leave them as the same numbers as before. I'm going to set up two different tables now, but everything else within the table is the same. So here are my widths of each bar, same on both of them. And then we're just going to go through each data set to count up the frequency. So for those who like to shop online, all the numbers that I have between 0 to 8, there are 1, 2, 3, 4, 5, 6, and not including the 8, so just 6 of them. And then from 8 to 16, 1, 2, 3, 4, of those. 16 to 24 would just be the 22, so just 1. 24 to 32 is just 1, and then 1, because there's a 38 that's between 32 to 34. We do the same thing for in-store, 0 to 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, don't include the 8, so there's 10. And then 8 to 16, 1, 2, 3, 4. 16 to 24, just 1. 24 to 32, just 1, and then nothing from 32 to 40. Okay, so there are my frequencies. And then this time, while we're here, let's do an example of a relative frequency histogram. So if we wanted to make a relative frequency histogram, then we would need to add a column in our table for relative frequency. So to find our relative frequency, we want to take our frequency, so for this first row, 6, and divide by our total number of data points that we have just in this category of the shopping online. So I believe there's 13 total, and then we would get that as our decimal, which is 46%. Okay, we do the same thing with all our others. It is for my people who like to shop online. Here's all my relative frequencies. Let's do the same thing for the in-store people. So again, 10 divided by, and then the total in this data set, adding all of my frequencies up, I get 19. So that would be rounded to 53%, and we continue. We've got all their relative frequencies. It's time to make our histograms. Two axes, one for each set of data that I have for each of the groups. I've labeled the y-axis with relative frequency. My x-axis, as you can see, all the numbers are the same for both histograms. I've labeled it with the number of pairs of shoes for people who like to shop online and the number of pairs of shoes for people who like to shop in store. So on my y-axis, now I just need to see, based on my relative frequencies, what's the highest number I have, because that's what I would need to get up to. And it looks like it's going to be 53 out of all of the numbers that I have. So that means on both y-axes, I need to make sure I get up to at least 53. And the numbers that I go by on my y-axis needs to be the same on both graphs. By tens, like in 10% increments. On my y-axis, I just got lazy and labeled only the even ones though. As long as they're both the same, we're good. So now we can start graphing all our percentages for each of the graphs. So for our people who like to shop online, we start from 0 to 8 with a percentage of 46%. So that's about right here. My bars, 31%, like right here. 8% for the rest. So it's down here-ish. Okay, pretend you drew yours a lot neater because those should all be the same heights. Ugh, okay, and then let's do the same thing for our people who like to shop in store. So 53% is about right here. For my first bar, 21%. For the next two, just do that. 5%, and then 0%. Okay. So there's my two histograms, and now we can see for both graphs, whether you like to shop in-store or online, the graphs are skewed, so the distributions for each data set are skewed to the right. Whether or not you shop online or in-store, it still seems like there's not much of a difference because both of the graphs look very similar. That's how you're making histograms. That's how we're comparing histograms. That's it for these set of notes. Hopefully this makes sense. If not, send me a message. Let me know what questions you have. Good luck.